Hi and Assalamualaikum to all fellow panels. My name is Muhamad Haziq bin Baharuddin. I am from 3 BMMV 1/1 with material number B0919100045 and I'm the supervisor Mr. Saikushari bin Sainuddin. Today I want to introduce you about my title for PSM1, which is study on reduction, strength and hygroscopic growth of aging of FS 3200 polyamide nylon material by using sintering laser selective based on non-coating condition. We go to the chapter 1 is the introduction, the background study, and firstly to define water is one of a kind universal substance that is essential to all living beings. Since antiquity, philosophers, naturalists, and scientists have been fascinated by its nature and qualities. Other than that, the water pollution due to this 21st century also defines some quality and quantity issue which is affect the human and become the biggest challenge nowadays. And the project linked to the RTCS, which is river trash collector system, and hydro quality system, which is a HYGROSCOPIC project, have the same goals of reducing river pollution for the future research and innovation. The innovation of the RTCNS and HYGROSCOPIC has been selected the nylon FS 3200 polyamide as the main material that can be printed by sintering laser selective SLS, and the strength of loss and hygroscopic growth aging has been need to be testing and analyzed for the water quality device. And for the problem statement, we go to the first problem statement, which is the production of the HYGROSCOPIC also depends on the some factor for affect pollution in the Malacca River, such as the pH level, water current flow speed, temperature and humidity of the surroundings are all monitored by this device. And next, we go to the material of nylon selection to be print for the body part of the HYGROSCOPIC. And the third one, the tensile strength of the position product printed has been affected when the SLS machine printed the product. And the last one, which is the surface roughness of the product affected by power supply of the SLS machine. And we go to the objective. We have 4 objectives, and the first one to define the best position of the nylon FS 3200 polyamide specimen in the SLS machine to identify, and the second one to identify the best laser power by the SLS machine during the printing process. The third one to define the best surface roughness of the nylon FS 3200 polyamide, and the last one we want to analyze the effect different condition of the testing nylon FS 3200 polyamide. Next, we go to scope of research that we conduct for this project, which is we go to the literature study of the material properties, mechanical properties of hygroscopic aging of FS 3200 nylon material and nylon powder by using SLS 3D printer, water pollution, and we cover the UV radiation for the exposed to the sunlight. And the second one is the field testing for the test sample that we want to put under the UV radiation for the further tensile test of the FS 3200 polyamide for being tensile test to get the stress strain graph. And the last one, we go to the tensile testing by the nylon to before and after the field test. So next, we go to the chapter 2, which is a literature review. Firstly, I want to introduce about the water quality monitoring device innovation that called HYGROSCOPIC. HYGROSCOPIC is the new technology that implemented by using an open sources of Arduino platform electronic. And the body part of a HYGROSCOPIC is made of nylon FS 3200 polyamide that we want to analyze the strength reduction of the body part by using the tensile test. And we go to the sintering laser selective process, which is defined as a rapid prototyping technology employed with polymer powders to fabricate product layer by layer with various properties that are comparable to those obtained by injection molding. An additive manufacturing process that use a higher power laser beam act as to sinter tiny polymer powder particles into solid structure based on the 3D model has been designed and averaged at the SolidWorks that implement to the software. And the selection powder is nylon FS3200 polyamide. And we go to the sintering laser selective machine that we have 4 primary chambers, which is the feeder chambers, building chamber, collector chamber, and powder overflow chamber. Other than that, the SLS 3D printer also consists of a laser that used to print product that support by the power supply, and the specimen will print on the Person FS4092P SLS 3D printer with their own dimension, and we can see the FS4092P SLS 3D printer at the figure 4 that we use at the laboratory and the FTKMP. Next, we go to the nylon FS3200 polyamide material. The first, we want to introduce the nylon FS3200 polyamide characteristic. We want to highlight the tensile strength of the nylon, which is the 48.1 megapascal, and the elongation break at break, which is the 38%, and the melting point of the nylon, which is the 183 degrees Celsius. So we can see the figure 5, the nylon structure, and the nylon specimen has been printed by the SLS 3D printer. In the SLS process, the material of FS3200 polyamide has been used to reproduce the sample of the specimen as shown on the figure 6, and the specimen were printed using the standard performance process parameter of the polyamide 12 provided by the EOS manufacturer, and the dimension of the specimen printed is 246 mm times 29 mm times 10.5 mm respectively to length, width, and thickness. And next, we go to the position and angle of the specimen in the SLS machine. As we can see at the figure 7, the design of the specimen that arranged by the orientation as shown at the figure 8, the different orientation due to the XYY and YZY and YZZ. But for this project, we just focus on the XY, Y, 0, 30, 60, and 90 degree, while for the YZ specimen orientation, we just focus on 0, 30, and 60 degree. So for the orientation, we can see at the figure 8 that show the XYY and YZY and YZZ for the specimen of nylon FS3200 polyamide. Next, we go to the chapter 3, which is the methodology. First, I want to introduce the field testing process for the non-coating nylon FS3200 polyamide. Will undergo the 3 major methodology, which is the first is the selection of water, the testing for the specimen, and the duration of testing. The first thing, we go to the selection of water, which is the 3 types of water has been selected, such as river water, sea water, distilled water. And the river water we collect from the Melaka River, and sea water we got from the Pengkalan Balak. And the data mass has been collected and examined throughout the tensile test and surface roughness test. And the test duration of testing we conduct within the 2 weeks for the duration. Next, we go to the data gathering before and after field testing for the samples. The first task, we conduct the measurement by using vernier caliper to ensure the thickness, width, and length. And the second task, we conduct the tensile testing by using the Instron 600DX to get the Young's modulus value, maximum tensile strength, and the tensile strain, with extension at the break. And the third task will be conduct the surface roughness test by using the portable surface roughness tester SJ301 to get the measurement of the surface roughness. And the last one for the fourth task, we collected the data, and the specimen has been exposed to under the sunlight, and we want to get the UV value, humidity value, and the temperature from this methodology. Next, we go to flowchart of this project. Start with the problem statement, literature review, a planning of methodology, and we go to the sample preparation of the SLS. And SLS will print the specimen and will undergo 3 major testing and observe about the surface roughness, tensile testing, surface morphology. And the specimen will be soaking in the water, and next we use the specimen to expose to the UV sunlight, and the analysis will be conduct after the exposed to the UV sunlight, and the end of the project. So I want to introduce the equipment that we use for the tensile test, which is the Instron 600DS tensile machine, as shown at the figure 10 for the body part of the Instron 600DX. But we want to highlight the test space for the tension and compression, that space that we put the specimen to undergo the tensile test. And we can see the actual Instron 600DX machine that we use at the laboratory. So the Instron 600DX tensile machine connect with the Blue Hill software that conduct the data of the specimen when they undergo the tensile test. So we can see the figure 13 for the specimen Instron 600DX ready for the tensile test. And next we go to the second equipment, which is the portable surface roughness SJ301, which is the portable surface roughness that we use for the measurement. Can be performed in any position, including vertical and upside down. And the portable surface roughness tester have a higher resolution, high speed printer incorporated into the main unit, can print 5 set of measurement setup at the end of the measurement. And optional accessories such as a high gauge adapter can provide the accurate measurement in a variety of setup for the portable surface roughness SG301. Next, we go to the chapter 4, which is result and discussion. The tensile test for the nylon FS3200 polyamide has been conducted by the Blue Hill software that connect to the Instron 600DX tensile machine, that come out of the result for the tensile test. And the reading of the sample include the XYY 0, 30, 60 and 90 degree, while YZY for 0, 30 and 60 degree. The data of the tensile has been calculated, the average reading for the value of Young modulus, tensile strength, and the tensile strain with extension at the break. So we can see the specimen nylon break on the Instron 600TS when undergo the tensile test. So for the data and graph for the tensile test, the table 2 data shown that SYY orientation, which is defined as the 60 degree position, has highest Young modulus value with 684.57584 compared to others. And the data of the YZY orientation, we define the 30 degrees position of the specimen has the highest young modulus value, which is 608.346265 megapascal compared to others, and the curve of the graph by the XYY is higher than the curve YZY graph stress trend for the 0 degree orientation. So that's all for my PSM1 research, and for the further PSM2 we will conduct the specimen to put under the sunlight to get straight UV radiation to get the UV value, humidity and the temperature, and the specimen will be sent back to the laboratory for the undergo tensile test. That's all from me. Thank you.